Hey there, this is Kit again. This time somehow I want to do a breakdown on paper 2. So this is actually paper 2. This is 2013 May. HL paper 2. This is paper 2 of time zone 2. And I would say for this year the time zone 2, both time zones for paper 2, both paper are kind of having some level of difficulties. There are one or two strange questions that is kind of new, and I definitely would say, why would they do something like this in the last year of the old syllabus? I think that's because they are setting the tone for the new syllabus. So when you're doing those questions, I think you should pay extra attention, and I will probably try to break them down after this series. But this question that I choose is not that strange. It's actually a common or kind of standard type for this type of questions. This is basically a related rate question. Okay, it's called a related rate question. So if you understand what's related rate, it's basically differentiation with a little bit of chain rule, and you're differentiating with respect to time. But anyway, it's quite standard. I just want to show how you do this kind of question because I don't know why somehow most students have difficulties with these. I don't know, because the question is so long or they don't know what they are supposed to do. So let's begin. This is question 13. Is basically the last question. It's kind of long, but it's not that hard. So question is like this. There's a street width 20 meters, so this is 20. Okay, I hope you can see. Parallel side, two vertical walls, one wall is 13, one wall is 8. Intensity of the light, blah blah blah, is proportional to the angle. Okay, this is the angle APB. So we have the intensity of the light here being proportional to the angle. Okay. So first thing first, find an expression of theta in terms of x. What's x? X is the distance of point P from the base of the wall of height 8. So it would seem that this is x. So obviously if this is x, using this 20, this would be 10 to the minus x. So all we have to do is to somehow find some formula linking theta and x. I have told you this is a very basic first step for all related rate question. You have to do this. You have to link the two variables inside the question. Obviously, now the two variables will be theta and x. So this is a great hint that you are doing a related rate question with the fact that you see some derivative here. I would say this is a classic setup. So all you need to do is use your mathematical knowledge to somehow link theta and x. It may not have anything to do with calculus, it may not have anything to do with the HL syllabus, just use your past knowledge. I assume if you're doing HL, you can do something like this. So, well, this is what I would think about. So this is a straight line. Obviously, this angle and this angle belongs to this two right angle triangle. This is right angle because they're wall. And obviously, both angles could be expressed in terms of x with a little bit of trigonometry, sine, cosine, or tangent. So that's what we would do. So if we tangent this, all right, let's call it A, whatever. So what we have is, we tangent A, we have h over x. That means A is just arc tangent h over x. Similarly, we call this B, okay, tangent B is 13 over 20 minus x. Arc B is arc tangent 13 over 20 minus x. In that case, theta is found. So theta is just 180 minus a minus b. But bear in mind that we will do differentiation in the future. I mean, in the coming parts. Whenever you do differentiation or whenever you do calculus, so integration or differentiation, whenever you have angles, you must express this in terms of radian. That's a basic rule. So instead of 180 degree, we use pi. So theta is just pi minus a minus arctangent h over x minus arctangent 13 over 20 minus. You may think this is kind of complicated and ugly. I agree, but I don't have any quick way to simplify it right now. I don't know any other way for now. And unless we can't do the following parts, I don't think it's necessary. Remember, this is paper 2, so a lot of stuff could be done by calculator, including this. Calculate the value of theta when x is 0. So obviously you just plug everything in. So if x is theta, it's kind of like this move to here. So the picture that you're looking at is simply this. Okay, where this is 8. Okay, this would be theta. Okay, this is 30. This is 20. So you're looking for this angle. So is obviously, okay, theta would be 90. This is 90, right? 90 minus this angle, which was b there. So it's 90. 90 is pi over 2 minus arc tangent 13 over 20, which of course we should calculator. Okay, I hope you can see if I change it to radian mode. Okay, remember to do this every single time, because if you reset the calculator or anything, the setting would go off. So pi over 2, where's pi? I'm so bad with this calculator, actually. I hate this very much. I would say it publicly. 994. Usually 3 significant figures are enough. Calculate the value when x is 20, so it's basically the direct opposite. So it's like this is 8, this is 20, this would be theta, this is 8, this is 8, so theta is pi over 2 minus arc tangent 8 over 20. Let's see what that is. Pi over 2 minus answer what 1.19. Okay. So now we move on. C, sketch the graph of theta. Okay, so this is the formula for theta. This is the formula we found. Sketch graph. We never do it by ourselves in paper 2. Just plug everything in. So pi, let me do this. Pi, arctangent. We need a fraction 8 over x minus arctangent 20 minus x, close bracket. Now x is between 0 to 20, so you need to set your window. Well, x is 0 to 20, that should be enough. Y we kind of don't know, so it's probably not negative. You know, theta cannot be negative, so 0 to, you know, it's in radian, so it's obviously less than 180 for the angle, so we can use pi as the maximum. It's probably good. See the graph. Okay, it's loading. Okay, that's kind of what we got. So just draw that. Okay, I'm kind of running out of space, but anyway, let's draw it here. Okay, this is x, this is theta, and we have a point here. According to the graph, going up and down, so up and down. That should be good enough. B. So this is 20. Maybe we would find this. Okay, so we can calculate when x is 0. What is it? Oh, just give me. Never mind. It's probably useless. Next, show that I need to differentiate stuff. Okay, so let's do that. Theta is here, so differentiate theta, dx, right? Yeah, with respect to x. Okay, d theta dx. Pi, remember pi is just a number. Differentiate a constant, a number, you get 0 minus arctangent. How do you differentiate arctangent? One of the greatest characteristic of IB examination, you got a formula booklet. So you got to know what you got on the formula booklets. You actually got the derivative of arctangent. Differentiate arctangent is 1 over 1 plus x squared. Okay, so we will do that. So is 1 over 1 plus x squared. This is x. Is that it? Now we need to multiply. Chain rule, multiply, differentiate the inside, so differentiate that. That is basically 8 times x to the power of -1, so you have -8 negative x negative 2 minus, do the same here, 1 over 1 plus x squared times. Okay, what about that? That one is -13, 20, negative x, negative 2. Well, there's a negative in front of the x, so chain rule again times -1. Okay, this is pure differentiation. I really would hope that you can do this. Okay, otherwise take some time. You have to be able to do this on your own. 13 squared is 169. Negative, negative, positive. Okay, we continue. 1 over this. You flip it up. The x squared and x squared cancel out, so it's negative, negative, positive. 8 over x squared plus 64 minus, flip up, cancelled, 1 over square plus. Okay, so we're the same. Okay, it's kind of good that we have x squared plus 64. We do. Seems that we need to get a common denominator, add them up, and we seems to have to expand this part. Okay, we have the x squared plus 94. This is a positive. So expand this. So negative x squared is just x squared minus 40x. Okay, plus, 20 squared is 400. 400 is 5, 6, 9. By the way, you got to be able to expand that quick. Okay, that's what they got. Okay, do cross multiplication. So -8. Okay, maybe not this whole thing. We multiply that to -8. Okay, sorry for the mess. Okay, this minus. No, this is a plus. Okay. Well, I would say this is tedious, but normal procedure. I hope you wouldn't do any mistakes here. I hope I wouldn't do any mistakes here, because examination is all about your condition. So if you have done enough math, your condition should be up. But me, okay, as a teacher, I don't really do this much of actual calculation nowadays. I usually just ask my students to do it. So I may be a little bit rusty, especially with the calculator. I hate this one. Never mind. Oh, sounds like we need to factor out 5. I don't have any 5, and that is totally not a factor of 5. Okay, I just made a mistake. What is that? Oh. Oh, there's a -13 there that I missed. Oh my gosh. What about sign? Negative, negative, positive. So this is negative, so I just miss a 13. Oh my god. So there's a 13. There must be a 13. So minus 13 with 64 times 13. Oh my gosh. I'm so sorry for this, but well, you get the point. In your exam, you probably can't do this because in the HL, odds is, unless you're really quick, you really fast, you would not have much time to do checking. So 8 minus 13 is -5. So you can't really commit the mistake that I just did. I'm lucky that this time the question gives me the answer, so then I can check, so that I can figure out my mistake right here for the 5. But you probably don't want to risk that. So, well, just be careful, because when you do your thing, you won't be doing your stuff and talking at the same time. You're not supposed to make any noise anyway. So, hope you won't do what I just did. Okay? It's basically correct. Okay, my answer. Terms are in different orders, but whatever. E, using the result in part D or otherwise, determine the value of x corresponding to the maximum light intensity at P. Wow, this is where the long lost information is useful. The light intensity is proportional to the angle, which means if your angle is maximized, your intensity is also maximized. So the question is, when is theta maximum? All we said is, well, this is the maximum. Come on. Nobody would use part D. Just go back to your graph. Go back to your graph and find the maximum. So ask for it. Okay, I may miss the bound setting procedure. Anyway, I'm sure you know how to find maximum with your calculator. This is taking a little bit of time. Oh, this is annoying. A little wait for it to go down. Step first. Okay, it should be good enough. Bam, bam, bam. Okay, same size when x is 14. 103. That's my answer. Okay, sorry for the delay, but yep, you may notice the answer is different now. I changed my setting simply because I input the wrong stuff into my graph, into the calculator. Alright. I guarantee you there is nothing wrong with my calculation, okay? It's just that in the last step, if you check the video again, when I input this function, I did something wrong. So now I have to basically redo the last part of my breakdown. Sorry for that. Okay, it's my second mistake during this breakdown, right? Oh, I hate that. But anyway, the maximum actually occurred as 10.05 instead of that. Okay, it's a simple error, input error. Okay, so that's it when theta is maximized. Well, you heard me say this question is about related rate, but there's still no related rate yet. It happens to be at part F. The point P is now moving. The point P now is moving across the street with speed 0.5 meters per second. Determine the rate of change of theta, okay, with respect to time when P is at midpoint. Okay, you need to understand every part of the question. What does it mean? The point P is moving. The point P is moving. Well, this is x. So if this move, x would move. This point move at a rate, or you call it speed. Speed means rate of change of 0.5. So actually, the first sentence is telling you that the x dt, the rate of change of x, is 0.5. Okay, because x is moving. The second part, determine, that's what they want you to find. What do they want you to find? Determine the rate of change of theta. Rate of change of theta is simply d theta dt. When P is at the midpoint of the street, what does that mean? P is at the middle, that means x is 10. So that means when x is 10. Okay? That's all we need. That's all we need. Okay? Note that on top here, we have d theta dx So, and you're looking for d theta dt, so obviously d theta dt equal to d theta dx times dx dt. This is true kind of because dx and dx will cancel out like a fraction. Well, due to something called differential, this is actually true. You can just accept it for now and then do a little bit of digging in university, okay? But this is all you need to do. So d theta dx is that big thing, right? So how do you get a value? Because you have x equal to 10. So you do d theta dx when x is 10 times dx dt. Dx dt is given to be 0.5. So the rest is just pressing calculator with x being 10. So I don't know. It seems to be a bad day for me, so I don't think if I should be even pressing the calculator here right now. Divided by 10 to is 100. Okay, I need a bracket. 100 plus 64. Divide again, bracket 100 minus 400 plus is so small. Probably, is it wrong? Times 0.5, right? Times 0.5 is 2.2667 blah 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 e to the power of -4. So you move the decimal point to the left by 4 points, so it's 0.000227. 3 six figures usually enough. Okay, 1, 2, 3, 4. Okay, that looks right. That's it. This is my breakdown. Okay, it's not a perfect breakdown. I make some error, but this is totally how you do a related rate problem. Okay, so all you do is somehow find a way to link the two variables inside the question. This would be theta and x. Anything would be fine. What you do next, okay, BC is basically useless, just to get you some point. What you do next is you would differentiate it. Usually, in this part, you already differentiate it with respect to t. If you do with respect to t, then all you do is you need to do chain rule again and then multiply dx dt. Okay? But anyway, we actually do the same at the end. So like, all you need to do is you need to understand what the question is giving you. When they say a point is moving blah blah blah, it actually means dx dt. Determine the rate of change of theta, so that means you need to find the theta dt. When p is at the midpoint, that means x is 10. You need to decode all this information, otherwise you cannot do the problem. The rest is just pressing calculator. So I hope this would help on how you tackle some question like this. And well, thank you very much. It's kind of a rush for me to suddenly do this because honestly, I was doing this for a student that I work with. Okay, I didn't have enough time to go through this with her during the last lesson. So I hope this would help her. I don't know if she's watching anyway, but sorry, this is a rush and I made some mistake. But I hope you enjoy. I hope you learned something. Goodbye.